Welcome grade 7 to another math video. In this one we're dealing with area again of a rather strange shape, a shape called a trapezoid. Now to solve a trapezoid, it's kind of going to be a combination of how to solve a parallelogram and how to solve a triangle question as well. First of all, a trapezoid is a quadrilateral, meaning that it has four sides. That only has one pair of opposite parallel sides. So instead of having two like a parallelogram, we only have one. So we could have a number of different shapes for a parallelogram. You could have ones that look like this, where again this and this are parallel. You could have ones that look like this, where this and this are parallel. You could have all sorts of different ones, but you'll notice here that these sides are not parallel, these sides are not parallel, so we only have one pair of parallel sides here. In a particular trapezoid, there's an interesting trick that we can use with trapezoids, and that is that no matter what, if you take two trapezoids and put them together, you get a parallelogram. So let's take a look. So let's say I have a trapezoid that looks like this. If you were to take an exact copy of this and put it right beside, but flipped, you would end up with a shape that looks like this, which really, when put together, is a parallelogram now. And we're going to use that bit of information to figure out area. So if we think about this as sort of like a parallelogram, remember that our parallelogram formula, parallelogram was base times the perpendicular height. Perpendicular height was the height between the two parallel lines. Well, we're going to use the same idea here. A trapezoid is kind of like the same thing, where we have base times perpendicular height, but we have two of them. So in this case, if we think about this whole parallelogram, we have this, our base, our whole base here, is this base plus this base, these two bases together. What we sometimes say is base 1 plus base 2. I know this is not a base, this is a base, but it's really the two parallel sides added together times the perpendicular height here. But that would give us this whole big parallelogram shape, but really we only have half of it for our trapezoid. And so it's this divided by 2, or times 1/2. So it kind of gives you an interesting formula this way. The book likes to say it as that the area equals 1/2 times the sum of the parallel sides times the perpendicular height, or 1/2 times, sometimes they think of these as A and B, A plus B times H, or sometimes I've seen it B1 plus B2 times H divided by 2. There's many different ways that you can write the same thing, but all of these will help us solve the particular area of a trapezoid here. This is the end of the lesson portion. We're now going to go into the example section as we step through example 7 and example 8. You can either start your questions now, or you can stick around to see how those work, which may help you with the try it questions too. All right, let's start off with example 7 here. Example 7 says that we're given a parallelogram, or sorry, we're given a trapezoid, not a parallelogram anymore. We're given a trapezoid here. We're told that we have a base here of 15, we have a distance here of 9, and we also have a perpendicular height of 8. It says find the area of this particular shape. Well, remember that area equals 1/2. Sometimes I like to write this way. Sometimes I write 0.5. Sometimes I do it divided by 2. There's no wrong way to do that. They work all ways. It's just a matter of what you're more comfortable with. Times base 1, which is 15, plus base 2, which is 9, times a vertical height or a perpendicular height of 8. So I'm just plugging in what I know into the formula and solving from there. So now area equals 1/2 times, brackets first, remember order of operations. So 15 plus 9 is going to be 24 times 8. Area equals 1/2 times 24, or 1/2 of 24 is 12 times 8. And so all we have left to do is multiply that to get an area of 96 centimeters squared. So that's how we would use some of the given information in order to solve the question for example number 7. Example number 8 gets much more challenging as it goes through taking what we know and putting it into a bit of a different context. It says the figures show a horse trough. So now we're kind of dealing with a bit of a three-dimensional shape here. See if I can draw it out a little bit this way. So we're dealing with a three-dimensional shape. We're given some of the values. We're told that this is 50. We're told that it has a vertical height here of 36. We're also told that it has a length here of 200. That's this kind of dotted line. It tells us, or asks us, to sketch the cross section and label its dimensions. In your try it questions, you won't have to do that. Really what they're looking for is basically saying this is a three-dimensional shape. Please turn it into a two-dimensional shape, which is kind of just taking the front of it. So if I did that, then that would give me this is 50, this as 36. Really what they're asking here, or what they're trying to figure out, is what would this look like, and how could we figure out some of the area of some of this stuff without having to worry about what this 200 is. So technically this would be the cross drawing of it if I were to just take a slice off that and make it two-dimensional instead of three-dimensional. B says if the area of ABEH, so the area of the trapezoid here is, so B, the area equals 2,250 centimeters squared. What is the length of HE? So we're asked to figure out this one here. All right, so this is getting a little bit trickier because our area formula is trickier. So our formula, remember, is that area, or 2,250, equals 1/2 times base 1, which is 50, plus base 2, which we don't know, base 2, times our height of 36. Okay, so let's step through. We have to eliminate so that we could figure out B2, so that we could figure out this height here using what we know. So let's start by eliminating 1/2. So remember, this is the same as divided by 2. So I times 2 to both sides to get rid of that. 2,250 times 2 is going to be 4,500, and then these cancel out, equals 50 plus B2 times 36. Next step, divide both sides by 36. These cancel out. 4,500 divided by 36 is going to give us 125. I now have 50 plus B2 left. The only thing left to do, I just have these left so I can get rid of those brackets, is to get rid of this plus 50. And my way of doing that is subtracting 50 from both sides. And when I do that, I figure out 125 minus 50. I now have a base 2, which is really this length here, the top length here, of 75 centimeters. So that would be how you would step through that particular question. Try 8 is very similar as you step through and as you work at solving that particular question too. Hopefully that helps as you go through those particular triads.